So I'll just hand over to Robert. He's the founder CEO for Wadaro. It's eSim that can be used everywhere in a telco for a whole host of applications. So I'll just hand over to Robert and let him share all the cool stuff that they're doing and will do in the future.
Thanks, Alan. Can you see the PowerPoint?
It's coming up. It's you've started sharing screen. There you go. It's there.
Okay, so yeah, the grandiose claim, we give SIMs superpower. So we're talking about SIM cards, eSIM, single board microcomputers that run in mobile phones that people tend to ignore. Yeah. They are actually quite a useful utility, very powerful piece of equipment, especially when they're deployed in volume as they are. So in our world, this is quite an apt phrase. We're talking about mobile network operators improving their service so that people have a better experience of them, and to be able to tune anything, to change anything, to control anything, you've first got to be able to measure it. So hence this phrase, you can't manage what you can't measure.
Yep, it's very, it hits across a number of topics in telecoms. So it's a very important phrase.
As I get into this, I explained a couple of reasons, well, a couple of methodologies that network operators have been married to for the last 40 years, and they should think about something else.
Yeah.
So we're unlocking the capabilities of the SIM card using Java card applets in the SIM. We have actually got proven technology because it's been deployed by customers in various parts of the world. We're doing extremely well in the US, well, in the Americas generally. We are the standard for KPI reporting in Nigeria. We've got another country coming online in the not too distant future, and we're up to some stuff in Japan. And we've gone from just worrying about customers with retail handsets to those that have modems in cars and what people are calling IoT today, which used to be telematics in yesteryear.
Exactly.
So the purpose of our products are to report the performance of service as delivered to the individual. Along our journey, we've developed a component architecture in the SIM and server side that enables us to rapidly adapt our product to meet customers' needs, but also to copy and paste into new products. We get requests fairly regularly for the use of our technology beyond what we're doing currently. One of the interesting developments that we made probably 4 or 5 years ago was to implement and patent a method for calculating the latitude, longitude position of a device without using GPS. So it is an approximation, but it performs extremely well, and we can get great accuracy, which is dependent on cell density. So if you go into kind of an urban context, we can even get down to single-digit meters.
Wow.
And we developed this because we wanted to anchor customers' experience in whatever the network operator's addressable geography is. That way we can say, here is where people can't get radio, or here is where they have had drop calls. So this is the way that it's been done to date by network operators. This is a method and technology which has been used from the very beginning. I'll ignore analog telephony, but let's stick to digital. So 35, nearly 40 years now. On the left, you can see a couple of PCs on some specialist equipment with a bunch of phones plugged into it, obviously in a car. And that is a vehicle that's going to be driving around a predefined route at a predefined time, capturing radio data and also generating traffic as well. So it's a tool that's been used by network operators forever. And the other method that they've been using is core network probing. So if you think about a mobile network at its heart, it has a very large enterprise scale IT system, and each of the elements inside that IT system produce management reporting, and you can take that out and put that into reporting. So fundamentally, network operators have been either staring at the core network or drive testing and using that to determine our own experience of their service. And it really has nothing to do with it. I mean, it's the reason I started the company 20 years ago was fundamentally because I got no signal at the back of my house, and I just decided to do something about it. Originally, I was going to make myself some kind of Pringle tin repeater, but after reading the specs and talking to people, I decided to start a business and do it for everybody.
Cool.
So drive test is very, very expensive. Yeah, on average in the US, a carrier is spending a couple $100 million a year just repeatedly doing the same thing. It's inaccurate because the vehicles only go where vehicles can go. They don't actually go where people go.
Yeah.
So if you take it away from a kind of US context and go to somewhere like the jungles of Kerala, you can't get vehicles in some places there, but people still manage to get about in the jungle. You can't test it, but they still use mobile phones there. So it is inaccurate. Stale because it's a bit here in the UK. We've got a bridge called the Forth Bridge. You start painting at one end, you get to the other end. When you finish painting it, you pick up your paint pots and go back to the beginning and start again. By the time they've captured this data and they've reported it, conditions can change. Weather changes radio, foliage in trees changes radio, density of people at sports fixtures produce congestion. So network operators tend to use drive tests, and they're actually looking at something that changes constantly. So it really doesn't apply.
Yeah, or just simple geographic features. You're on one side of the hill, the road's on the other side of the hill, and it doesn't have to be a big hill, and completely different radio conditions.
Yeah, I think I might have an example of that in this slide, where a volcano that people don't go up. I'll show you. The other thing about it is it's irresponsible.
Yes.
Because you're spending that much money on vehicles. You can just extrapolate from that how much fuel is being burnt and the tons of carbon which are being emitted needlessly. Mm-hmm. And if you multiply that across the 1,000 network operators globally, it's a lot of carbon.
Yeah.
So do it our way. All you need to do is instrument SIM cards with our software, issue them to your customers. That can either be physical SIMs that they get that are new, or you can send the application over the air silently. It's not very intrusive, and especially these days with eSIMs, you can add it to the profile before it's downloaded.
Yeah.
And then off you go. So this is a map of a new customer. They have literally been going no time at all, and they've distributed physical SIMs in this case. And you can see they're already getting a radio fingerprint where they've distributed those applets. And to the volcano remark, Alan, on the bottom right-hand corner, you can see a volcano. There's no need to drive test it because it doesn't look like anybody goes up there anyway. So,
yeah.
But fundamentally, this represents where people go and do what they do. So even boats offshore that can still get radio, we can show that as well. And if you go to countries like Indonesia, which are predominantly islands, that's pretty powerful because drive testing 430, I can't know how many, it's not possible.
Yeah, exactly.
Yeah. And this changes over time, weather changes it. People stick up new buildings with shiny surfaces, that changes it.
Yeah.
You have peak holiday periods, people congregate at a particular place, which is not that well planned. So when you've drive tested it and it's got a certain rating in terms of capacity, you then go to the summer and it's 3 or 4 or 5 times, 10 times as many people there. Networks struggle.
Exactly.
So a little bit about the kind of data that we capture. This is with respect to calculating the latitude, longitude, position of the device. What I'm trying to show here is that the SIM in the handset provides us with something called the network measurement results. We capture that. Network operators give us their cell plan, and through some mathematics, we blend the two things and we sort of calculate approximate latitude, longitude. And that graphic you can see there in the middle, that's Manhattan Island. And the denser the kind of pink color, the more drop calls there are. So coverage there in Manhattan isn't particularly good, which is understandable because it's got a lot of very high-sided, very shiny buildings.
Yeah.
So about the product, we obviously work in a kind of telco environment, so we have to adhere to standards. It's just the nature of the beast. So our application has been written to conform with various 3GPP, ETSI, global platform, IETF standards. The target devices that we install our software into currently, so modern day ones, are about 32K, 64K, or 128K in code space. The amount of RAM available to us is kind of proportionally similar. In the old days, the SIMs used to sort of 8K and 16K. That used to be a bit of a challenge. So when you're thinking about how the application has been implemented, it's very much a low-level embedded task. Developing software for SIMs is not absolutely straightforward because there are no in-circuit emulators or debugging tools that you can apply to the SIM. I don't know if you've noticed recently, but they don't have a keyboard or screen. So it's a good old-fashioned, write some code, stick it in, pop some diagnostics on the screen that tells you what's happening, repeat until it works properly. You do simulate handsets and operating environments, but that's quite an investment, which we have done. So it's not so bad for us these days. We still have to put stuff in debug code to pop up the screen, but at least we can simulate it to a great extent.
Oh yeah. Well, and don't forget, you have 20 years of experience doing this.
I do, yes. And 40 years of developing software products.
Yeah.
We're very fortunate in the documentation that surrounds our technology is kind of free and open. You can literally wander up to the websites and download the appropriate documentation. So that's pretty cool. And the tools that you need to develop Java card applications, equally in quotes, are free. You do download them from Oracle websites, and there is a license that you've got to sign, but generally you're not paying any money for it. The tools that you need to actually get your code into the SIM can be very expensive if you license them from SIM card vendors. And when I say expensive, tens of thousands of dollars, because it is a bit niche. There are a couple of websites where you can go and get reasonably priced equipment. We use all sorts. We buy them from SIM vendors, but we also buy the kind of little cheap stuff because I carry it around with me when I travel internationally. So if I have to whip out my trace tool, I can do. Sure. But there are a couple of tools that you can get for free, and the particular one that I would highlight is the tool for installing software in SIMs at the Trusted Connectivity Alliance, the TCA. It's a bit clunky, it's free, it's not very polished, but it does the job.
Cool.
And the other thing to just bear in mind that SIMs are secure elements. So they're like credit cards, SIM cards are secure. You do need to have the secret keys, which open the card for installation. You can only get those keys from the network operator or at their request from the SIM vendor. You can buy developer SIMs, they're available, they're not particularly cheap, but it's not like you could just take the SIM card out of your phone and go to it. Yeah, it's just not possible. So this broadly is the kind of architecture of our product. The phone graphic in the middle just shows the general breakdown of the contents of a mobile phone down towards the baseband level. So this is below Android, below iOS, and in fixed feature phones, below a bespoke user interface. Yeah. It's just a computer which happens to be connected. And we drop our applications on the top there. So at the top, you can see subscriber experience, but in the roadmap, there may be something around steering of roaming and user authentication. So if you think about all those myriad of authentication tools that you've got to go to every time you try and log on to something, you can probably just concentrate all that into one product, and it's just on your phone, which is really convenient. On the right-hand side, you can see the kind of architecture. We've got service side, a bunch of microservices running over Kubernetes. I listed some of the components that we've blended into the platform on the left there. So Kubernetes, Kafka, Mongo, MinIO. This is great stuff because it provides you with clustered technology, which is quite high capacity. It gives you flexibility in terms of throughput of your processing. Pretty good environment to be working in. We very much like Kubernetes because you have a customer of a particular size, they get the same product that a big customer with a bigger size gets. You just inflate it for the particular target customer. Easy peasy. So we are very much a company that's invested in a SIM-based product for data acquisition. That's our core. It's passive measurements. There are opportunities to do active measurement. I mentioned that we've got a component architecture. We can break things out to develop new products. It is carrier grade. It's got to be up, all the time. The reason for that is that you get a lot of traffic coming in from SIMs across the network. You can't ignore them because they would build up in some network element somewhere, and network operators tend to get a bit testy if you block up their equipment. So it has to be up 100% of the time to fetch that data and process it. If they put the data into something like customer care, then it's in the critical path to a service delivery, so it's got to be up. Yeah. The key thing about what we've done is it's relative to the problem that is solved with traditional solutions like drive test and core network probing, they're very, very complicated. You also get stuff like deep packet inspection at the edge of a core network, terribly, terribly complicated and overheated solution.
Yeah.
By massively distributing the computational problem to SIMs, it makes it so much easier and a lot cooler to work on. And we're very fortunate in a lot of the infrastructure that we need in the SIM is provided by standardized API, in particular cryptography.
Yeah.
So there's lots of opportunities there for technology in SIMs. That's it. That's what we do. That's our product, and that's the application.
Excellent. And as I said, well, I've been following you for like 20 years now. So it's great.
Yes. You've been following him, and then you brought him on the show.
Yes.
And then Johnny, aka Christopher Columbus, found the new land with Wadaro, and I'm the first one to put a flag there. I'm the chief evangelist, and he's quite humble in what he's created here. So we had Dave Horton on yesterday, and
Yes.
talking about how he's an ingredient brand, right?
Mm-hmm.
Right now, G&D, which is one of the largest SIM vendors and also the second largest printer of money in the world, they sell his product as GDIQ. So
Yeah.
he's the ingredient within their SIM deployment. I mean, currently he's got 4 of the 5 top mobile operators in the world from market cap, either deploying, or testing. The cat's out of the bag here with Wadaro, and really, I mean, I got a benefit from coming on and starting these podcasts with you because, like I said in the first podcast, I had to throw a net on him and find out if the mermaid was real. So he is super geek. He is everything that Cat Summit stands for, the ultimate geek. I mean, and to say this in a nice way, he's the only lunatic that spent 18 years engineering it down to the handset when everybody else was looking at the networks. So when you're in your house and it says 3 bars and you say, I can't get a call, those 3 bars mean nothing because nobody has a closed loop down to the handset. He's the only company in the world right now that's actually in SIM, in production, in market, that's been able to do this. I mean, IDEMIA has tried it. They were bricking phones. People have tried this. So I just tip my hat to the 2 Brits here. Alan, I want to thank you so much for the introduction, but it's been the most exciting time in my life in telecom because Robert's allowed me to be a chief evangelist. That's as far as I've gotten with Robert. But you just so Alan, so you understand a little bit more about what, and the audience understands more here. So, the mobile operators are spending $5 billion per year just on the equipment that goes in for drive testing. And then $10 billion altogether, roughly, in doing drive testing. And let's not even get into the climate aspect of it, carbon, and just the insanity behind that. I mean, if Greta ever gets her hands on this, she's going to be screaming at the mobile operators all through Europe because there's just no reason. So, it's like they're using a horse and buggy. And right now we have a Ferrari, and that's not even electric. It's running on air within the SIM. And then, I mean, did you know, Alan, even if you say you take your phone back to your mobile store, right? And then they have to put it in a box and send it back because they can't diagnose it on premise. So they spend tens of millions of dollars just shipping back phones that they can't can't do diagnostics on. So if you bring your phone back, they don't know. So this has been the most exciting time of my telecom career. And as far as finding something that's so unique for the market, and we'll be doing podcasts with Robert and getting it out there more. But game changer. That's just it. Super geek game changing, Alan.
So you've covered the drive tests, but there are a lot of other use cases because it's not just network performance; it's service performance. In that actually seeing the drop calls and maybe what was happening during that drop call, but also one that we've talked about in the past as well is finally, given it's 2024, soon 2025, closing down SIM boxes.
Yeah, this is where we're kind of developing aligned products based on the same technology.
Gotcha.
SIM boxes have been around for a very long time, and we
Yep.
have actually done data analysis and found them, and that's helped network operator fraud departments get rid of them.
Yep.
Networks will never admit to the fact they've got fraud, so you kind of tell them where they are, and that information disappears in a black hole.
Yeah.
SIM swap fraud. There's so many people having their bank accounts emptied and being just basically robbed.
Yep.
Because there's been a SIM swap and a Herbert's got hold of it and they're just taking from people.
Yeah.
We can stem that. I mean, that's me being conservative. I think we can get rid of it entirely. So there are other applications.
There was SIM swap because that's an interesting one. We've seen the carrier's employees being paid to do SIM swap. So how can you stop that one?
Yeah, I mean, it's about authenticating the user. I mean, my experience with a SIM swap is that I got disconnected from service for 3 days. They literally switch off my SIM. I have to wait 3 days for the new one to turn up, and they just assume that's gotten rid of the problem.
Okay,
if it's a guy in a store that's actually implementing that, orchestrating it, it doesn't matter. It's got to be the individual who owns the subscription who authenticates themselves to the network to do the SIM swap. The guy in the store is just a conduit for getting that to happen, so they can't interfere with it.
Gotcha. Understood. Oh, that's interesting.
And you talk about authentication. You talk about all these authentication products. I mean, the I in SIM is identity. There is no better way for identity for a mobile phone or a mobile phone user than SIM QoE, which is Robert's product, which is another product here. And then you get into steering and roaming, which is mind-blowing. So there's so many problems that Wadaro solves.
Yep.
It's just how many hours in a day, and he's expanding. And to be quite honest, it took him years and years to be tested to where the largest mobile operators in the world trust it that it won't brick phones or cause problems. So the sensitivity around the SIM and putting this product in there has really been the holy grail that people have even given up on.
Oh yeah, it's not easy at all because it's a very special, shall we say, type of programming. It sort of reminds me of the early days when we had the mess of mobile phone games. You had all these different phone types, and you were building Java apps, and and there was so many. There was just a diversity problem to get them working on all the different phones. And this is like it's easier because it's just using the JVM within the SIM. But all those experts, all those people with those abilities, have disappeared off into other embedded systems. Because it's so hard to break in to the SIM and to get the approvals from the telcos. So again, you got to, I always keep referencing that it took him 20 years to get here, but he's here after 20 years.
Oh no, he built it, and he built it, and they're coming. So I like to joke around and say, "I hear you now."
Exactly.
Yeah.
Cool.
That's something that Robert had to go, being in the UK, had to go and investigate all the commercials and stuff that were out years ago. Can I hear you now?
Yeah.
So it's really exciting. And we'll be doing many more podcasts with Robert and getting it out there. And obviously, this is the TAD Summit gold standard. And we've got some amazing companies, but there's just nothing in the industry out there that's solving the problems that Robert solves. And there's just not even a competitor within miles away. They'd have to start now. It'd take them about 5 or 6 years just to get tested in the operator. So just so you understand how an amazing find this was, and the relationship you have with Robert. So it's funny. It's a weird world, but giving me a crazy amount of excitement. Even people are saying, like, why aren't you posting? Why don't you do this? I'm like, I'm learning.
Yeah. Exactly.
Learning about Wadaro. I'm focused. I'm excited about all the good he can do. And he said something quite interesting about the information for SIM, and we talked about this yesterday. The operators, they can't, the lawyers can't admit that about this SIM box fraud problem. They can't admit it, because once they do that, they become culpable. And what
Yes.
happens is the regulators just want to sue them. So there's a catch-22, which really comes down to my thesis on lawyers are destroying the world, because they're not even allowed, the lawyers, the legal departments have to keep this hush hush. But as we know, and we're going to be having another podcast soon with a gentleman, some crazy stuff going on with Simbot fraud right now.
Yep.
That's been really, really bad. But it's really exciting.
Absolutely. So we're coming up on time. So again, Robert, thank you for the presentation. Congratulations on getting here and the broad adoption that we're seeing across some large carriers in certain countries. So looking forward to tracking your progress over the coming years. So again,
Cool.
Thank you so much, Robert.
Yeah, very welcome. See you around.